exponential function. So let's start by graphing or talking about an exponential function. Remember, exponential functions almost always spell in the form y equals a b to the x, right? Isn't that basic form? Where the a is the y-intercept. Thank you. And the b was the growth or decay factor. If it was a growth, then b was greater than 1. If it was decay, it was between 0 and 1. Okay. And of course, there was translation stuff that went along with that, and we could do lots of different things. So, very quickly, let's talk about example 1, graph. And I just want you to sketch the graph of y equals 3 times 2 to the x. Let's start off with an easy one. All right. Exponential function crosses at 3. That's the y-intercept is at 0, 3. So I'm going to put a dot there. And is this growth or decay? It is a growth, so we know it's going up. And remember, it's always approaching the x-axis, but can never cross it or touch it, right? It's really, 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 really small, or starts really, really small, but it can never cross that x-axis. All right. So since I have the drawing there, let's do domain and range. Domain is your x values. This can go forever this way, and that goes forever this way, so our domain would be, good, negative infinity to infinity. The range, correct, 0 to infinity, because it can get really close to 0 but can never touch it, so it's got to be a parenthesis, and it goes to infinity. Okay? If maybe I had a minus 3 here, then this would drop down 3, and all of a sudden, instead of 0 being what it approaches, it would approach this asymptote at negative 3. So it would be the same exact thing, just move down 3. Okay? All right. So the first couple questions you have in your homework today, really, I just want you to grab your graphing calculator, graph it in your graphing calculator, look at it, and state me the domain and range. All right? We're good with that? Okay. What if there was a negative in front of this? What would happen to this whole thing? It would flip it upside down, right? So the domain and range might look a little bit different, but all right. I want to talk about example number 2. One of the things we had to do was when we're talking about exponential functions, you had to manipulate the base once in a while to solve, right? So for example, if I said I have 8 to the 2x, but I want a base of 2. I need you to change this function, so this is a base of 2. So 8 is actually 2 to what power? 2 to the 3rd power, and I still have this 2x out here, right? How can I go about simplifying an exponent to an exponent? Yeah. So this would be 2 to the 6x. All right? So you have a couple of them today that you're just manipulating that base and rewriting the function. You guys okay with that? All right, I knew you would be. So, then let's get into the fun stuff. Solving exponential functions. All right. When we we solve exponential functions? Exponential functions can be, again, y equals ab to the x. It could also be a compound function. It could be an e, right? So maybe PERT might come into play today. Okay, you guys remember all those? Do I need to go over those? Just do an example of one using it? Okay, let's do that. So, example number 3. Let's say I want you to I want to start off with an easier one. Okay. Determine how long it will take to triple in value if the interest is 5.75% compounded. We're going to do an easy one. Continuously. All right. So first of all, continuously means that we're using perts, right? So let me put that up here. A equals PE to the RT. Okay. What information do we have up there? Well, we know what the rate is, right? So that's going to go in for R. We do know A and P, right? Because we want to know how long it's going to take to triple. So if P is 1, A is 3. If P is 2, A is 6, right? So we're going to say 3 equals 1E. Now how do I write my rate? How do I write that? Good. 0.0575 T. So out of this whole thing, we're solving for T. We want to know the amount of time, right? Okay. So how do I go about solving T? How do I get rid of the E in here? Natural log. Very good. So we're going to take the natural log of both sides, right? We have the natural log of 3 equals the natural log of E to the 0.0575T. Now, technically, what happens is this exponent goes in front, and the natural log of E equals 1, right? So we have the natural log of 3 equals 0.0575T. And then what do? Divide both sides by 0.0575. And T equals, what does T equal in this case? Two, 52.17. Try it again. Good. 19 point. Now, remember you're in AP now. You got to go to 3 decimal places. Always. 106 years. Okay? Always 3 decimal places. And you can either round or truncate. Up to you. But it's always to 3 decimal places. It's exactly what it is on your AP test. Always to 3 decimal places. Okay? All right. So, you guys remember doing that? You want one more example? No? Yes? Maybe? No? You guys want to just try some of them? What about a half-life? Do you remember anything about half-life? Uh-huh. So that's actually what is in your, that's your decay factor is a half or 0.5. Okay? So I think maybe it might do us good to try this, and then I can touch on what we don't remember how to do. Okay? Does that sound good? All right, let's get started. I am going to shut that door for a couple minutes, or Trayton, Trevor, when you guys want to grab that door?